Remember, y prime means dy dx in this case, because it's y and x involved. If it was y prime and t was over here, we would assume that y prime is abbreviation for dy dt. So when we have a differential equation and it's nice and simple, the derivative's already solved for, we can usually solve it by separating the variables. And what that means is you want to think about multiplying dx to both sides. So the right side I haven't done anything much with yet except I multiplied it by dx. And we want to have this right side be with respect to x and the left side be with respect to y. So I want to divide that 5y squared from both sides to get it out of the right side. So we get 1 over 5y squared dy equals natural log x dx. And so now we can solve this differential equation by taking an integral of both sides. It's balanced because we're doing the same thing to both sides. And then remember that this is y to the negative second. I'm going to factor out that 1/5. I'm going to put it as negative second so that the power rule in reverse makes a little more sense. And then when you're thinking about the integral of natural log, it's x natural log x minus x. And, oh, sorry, thinking ahead, plus an arbitrary constant c. You might remember this from Calc 1, but when you take an indefinite integral with no limits of integration, there's always an arbitrary constant c. And then if you're wondering how this is this, you could derive this by using integration by parts. You could let u be natural log x and dv be dx, and you work your way through the integration by parts formula. But this is just going to come up a lot in our Newton homework, so you could also just memorize that the antiderivative of natural log x is x natural log x minus x, and then if it's indefinite, plus some constant c. You can check me too, right? Take the derivative of this using the product rule, then take a derivative of this and see if they combine to make natural log x. Okay, and then this side we're just using the power rule in reverse. So that power goes up by 1. So it's going to be negative y to the negative first plus some arbitrary constant c. And then I've seen students say, okay, I've got arbitrary constant c on both sides. So that makes no arbitrary constant c, but that's not the case. So we should technically be labeling this. This is a different arbitrary constant than this one. If you subtract c to the second, c sub-second, I guess I forgot what that phrase is. What do you say for a subscript? C sub 2, right? Yeah, if you subtract C sub 2 from both sides, you're not subtracting a specific constant, it's an arbitrary constant. So any old number subtracted by any old other number is still going to be any old number. So when you combine these arbitrary constants, it's going to make just a new arbitrary constant, which Newton wants us to label as just regular C. Okay, so think about that carefully. This is any old number. If you subtract it by any old other number, then it's another number that's arbitrary. And then what are we doing here? We're solving the differential equation for y. So if I put this back in terms of a rational expression, this is negative 1 over 5y equals x natural log x minus x plus c. So to finish getting y by itself, I can multiply both sides by 5y. Then all this x stuff plus c. And then I need to divide all this x stuff from both sides and the 5 while we're at it. So I get that y, right over here, y is that negative 1 over 5 x natural log x minus x, and then you can just say plus c, because that c is inside the parentheses, but 5 times an arbitrary constant is still an arbitrary constant.